Greetings, welcome to my robot lab. For the present experiment, we will be determining the pulse width of a servo. This servo doesn't have any part number or a data sheet, so we'll be using the Moku Lab signal generator to go through the various pulse widths to find the correct minimum and maximum pulse width time. Here's the setup of the experiment. So right here we have our servo. It is a micro servo, and it is connected with its signal line to this row in the breadboard. On that same row we have a piezo speaker for auditory feedback, as well as a connection here, which goes to the multimeter. However, in this use case, the multimeter isn't actually that useful, but at least we will see some data from it. But anyway, so yes, as well, there is a probe connection on that same row, and this probe goes to the Moku Lab on the output port number 2. On the Moku, we are running the signal generator instrument, and in this case we're actually going to be focusing on the purple portion here because that is output 2. If we had something on output 1, it would be the green one, but right now we're just focusing on output 2. Okay, additionally, something to note is the servo is being powered from 5 volts, which is connected to the ST Mod Plus fan-out board. We'll probably go into more about that in a later video. Over here, this was for a previous experiment, which was to use the servo library on Arduino and inspecting that waveform. So for example, this was connected to the signal this was connected to the signal line of the servo going into the input 1 port. But that's not what we're here today to talk about. Today we're here to talk about determining the minimum and maximum pulse width of figuring out for the servo, which had no part number, no data sheet. So where would we begin? And that's what I'm going to show you now. There is one key assumption that we will be making, and that is that the frequency will be 50 Hertz. We have our servo here and a signal generator there. So as you can see, this part here, it's set to 50 Hertz. That's the frequency. So we can double check just to see the sort of time scale here. So if we enter 20 milliseconds, then you get this error here, pulse width limited by period, and that's because it would be the whole thing. So for example, if we go to 10 milliseconds, it will be half. Okay, great. So this setup basically makes sense for 50 Hertz and sort of gives us a sense of the time scale that we're working with here. Okay, so where should we start for determining the minimum and maximum of a servo? Well, one place to start would be starting at 1 millisecond. Now, this is just determined from experience, from working with various servos, many servos. We can start with 1 millisecond and either go less time, so left, or more time, right, and then determine from there what the minimum and maximum will be. Essentially, we will be scrolling through. I'm going to make one small adjustment here. That changed. So here we're just setting the voltage. Okay, there we go. That's better. Now, one thing is that the voltage of this pulse will only go to 2 volts. So we couldn't use an LED to measure it, but luckily the servo is able to receive that voltage and move. Otherwise we would have had to set up a different little circuit. Okay, so now we are ready to turn the output on. So we press this button and we see that the servo moved. So now what we're going to do is scroll through to figure out the timing of this. So we're going to choose that digit to sort of scroll through. Is the servo moving? There we go, now we start to see it move. Okay, so right now we're at 640 microseconds, and then we're going to sort of narrow down. We're now at 500, and sort of bounces around 400. So here we could probably safely say that 500 microseconds is that minimum value for moving the servo horn to there. So now we're going to go back the other way. We'll start at 1 millisecond again. The servo moved there. And now we will adjust it to go the other direction. Right now it's at 1.9 milliseconds, 2.1. Oh, it kind of goes funny there. So we'll go back. 2.1, 2.2 milliseconds. So here we see that the maximum value for the servo horn being there is 2.2 milliseconds. So now we can jump back to 500 microseconds. It goes all the way there. And we'll jump to 2 milliseconds and it goes back. Oh, that's interesting. Oh. 2.2 milliseconds, it seems. Alright. Another experiment idea will be to control the servo, now that we know its pulse widths, with the STM32L496 disco board. So there you have it. This is how you can use a signal generator to determine the minimum and maximum pulse width of an unknown servo. Another possible way of doing this would be to, say, use an Arduino and iterate through the write microseconds function. However, it is imperative that you be careful with this approach because you wouldn't want to accidentally go over the bounds of the servo already and possibly ruin it. Hope you enjoyed your micro visit to my robot lab. Bye.